Good afternoon, dear students. Yes. Okay. So, what we were discussing in our previous class? So in the previous class, we were discussing about the chemical properties, right? We were discussing about the chemical properties. Okay, so we had completed the physical properties of alcohols. Then we had started with the chemical properties. So alcohols, they act both as an electrophile as well as a nucleophile, right? So as they act as an electrophile and nucleophile. So so Okay. So we were discussing about the chemical properties of alcohol. That is alcohol. They act as what? They act as a your so they act as a electrophile as well as a nucleophile. So because they act as an electrophile and nucleophile, so two types of reaction can take place in alcohols and phenols. Okay, so they can act as a reactions in which cleavage of OH group takes place. Okay, OH bond is broken, and reactions involving the cleavage of CO bond. Okay, so these are the two types of reactions which is included. Fine. So in the previous class, we were discussing about what? We were discussing about the reactions involving the cleavage of your OH bond, right? We were discussing about the cleavage of OH bond. Okay. So these were the things we were discussed. So we have seen the reaction with metals. Okay. How alcohols and phenols, they react with the active metals like sodium, potassium, and aluminium. Okay. So when this alcohols, phenols, and ethers, okay, so reactions with the metals. So alcohols and phenols, okay, they react with the active metals like sodium, potassium, and aluminium to give the corresponding alkoxide or phenoxide, okay, with the evaluation of hydrogen gas. So we have seen this. So alcohols or phenols, when they react with the active metals. So when you have the active metals like sodium, potassium, aluminium, so we have seen that alcohols, they form alkoxides, and phenols, they form phenoxide. Okay, sodium phenoxides respectively with the evaluation or liberation of gas. Okay, so these were the reaction. Then we had started with the acidity of alcohols. Okay, so as there is a polar because of the presence of the OH group, okay, to the alcohols. Okay, so because of that, the alcohols, they act as what? They act as they are having acidic nature because it is containing the polar because of the polar nature of the OH group. Okay, so this OH bond, how it breaks? It breaks heterolytically. Okay, heterolytically means what? The oxygen will take its lone pair of electron and hydrogen will be left with no electrons. Okay, so heterolytic. So in the last class, I've shown you what is homolytic cleavage and what is heterolytic cleavage. Okay, so we have discussed about what is homolytic cleavage and what is heterolytic. So heterolytic means what? Heterolytic means the breaking of bond takes place unequally, right? So the one which is highly electronegative, it will take the electron pair with it, and the other atom will be left with no electrons. Okay, so it will be electron deficient. Fine. So this is the because of the acidity of these phenols, it depends on what? It depends on the OH group. Okay, the polar nature of the OH group. So it will form what? It forms respective alkox and alkoxide, and a proton is released. Okay, then we have also discussed about how alcohol is a weaker acid than your water. Okay, So next we are going to discuss about the effect of substituents. Okay, effect of substituent, that is electron donating group on acidity of alcohols. Okay, on acidity of alcohols. Okay, so next we'll see that what are the effect of substituents. Okay, that is electron donating group of acidity of. Okay, let me take a blank slide. So can you tell me what is electron donating groups? Yes, what are the electron donating groups? Electron donating groups. Yes, which are the electron donating group?
Water, hydrogen,
No, no. Your alkyl groups, okay? Like your methyl, then ethyl, okay? Then your isopropyl, okay? So these are what? These are your electron donating group, okay? So what these electron donating, or they are called as releasing group, okay? Electron donating or releasing group. So what they do? They will increase the electron density. So what is the role of the electron donating group? Okay, so this electron donating group, what they do, they will increase the electron density. Now, suppose you have a primary alcohol. So this is what R can be your electron donating group, like your methyl group. Okay, so what it will do, it will increase the electron density on this oxygen. Okay, on this oxygen. So what it will do, it will tend to decrease the polarity of the OH bond. So because of that, so this will tend to increase the polarity, that is electron density in oxygen atom. So because of that, the polarity of the OH group will decrease. Okay, so what will happen? So now suppose as you increase the electron donating group, what will happen to the this what that is the electron the polarity of the OH group, it start decreasing. Suppose one more this is attached. Okay, suppose one more electron releasing group is attached. So what will happen? So the electron density goes on decreasing. Suppose one more electron donating group is attached from for the alcohol. So you can see that what happens here, again it will decrease. Okay, so as you increase the electron donating groups on the alcohol group, okay, so what is happening? The electron density is increasing on the oxygen. As a result, the polarity of the oxygen, it goes on decreasing. Okay, so this is the this is your this. Okay, about the electron donating group. So electron donating group, what it does, it increases the electron density. It increases the electron density on oxygen. okay, which tends to decrease. Okay, I'll write like this: decrease the polarity, which tends to decrease the polarity of OH bond. Okay, of OH bond. So what will happen to the acidic strength? It goes on decreasing. Okay, as the number of electron donating are increasing, what is happening to the acidic strength? The acidic strength goes on decreasing. Acidic strength goes on decreasing. Okay, it decreasing. Okay, so this is about your effect of electron donating group. So as the number of electron donating group increases, what will happen to acidic strength? It goes on decreasing. Okay, so this is the effect of substituents. Okay, next we will see the acidity of phenols. Okay, next we are going to see the acidity of phenols. Okay, what is the acidity of phenols? Now, what do you mean by acidity of phenols? So we know that what is the structure of phenol? So this is the structure of phenol. Okay, aromatic ring with a OH group. Now here, phenol, it is acidic in nature. Okay, why it is acidic in nature? It is due to the presence of this OH group. So because of the presence of OH group, phenol is acidic in nature. Okay, it is acidic in nature. Now, this OH group in phenol is how it is attached. It is directly attached to a sp3 carbon. Okay, it is attached to a sp3 carbon. So what is happening here? So the OH group, what is happening to OH group? So OH group is attached to the sp2 hybridized carbon. Okay, and this is more electronegative. Okay, so this sp3 hybridized carbon is more electronegative. So what will happen? The polarity of the OH group, it goes on OH bond, it increases. What happens to the polarity? The polarity of the OH bond, it increases. So when you add this OH, okay, when you when you put this your phenol, okay, in the aqueous solution, what will happen if you put it in the aqueous solution? It will give you a phenoxide ion. It will give you a phenoxide ion plus a proton is given out. Okay, and a proton is given out. So this is the acidic nature of phenol. So we know that the acidic behavior of phenol, it is due to the presence of this OH group. Now this OH group, it is attached to what? It is attached to a sp2 hybridized carbon. And this sp2 hybridized carbon, it is more electronegative. Okay. So as a result, what will happen to the polarity of the OH bond? It goes on increasing. The polarity of OH bond, it increases. Okay. So when you put this phenol in the aqueous solution, how it will split? It will split into a phenoxide ion. Okay, it will give you a phenoxide ion and a proton is released. Okay, and a proton is released. So this is about your what? This is about your this, okay, acidity of phenol. Now, in case of alcohols, what we saw in case of alcohols, yes, when alcohols are added in water in the aqueous solution, it will give you alkoxide and one proton is given up. Okay. Now here, your OH group is attached. The polarity of the alcohols depends on the OH group. But here the OH group is attached to what? It is attached to a sp3 hybridized carbon. Right, it is attached to a sp3 hybridized carbon. Here the polarity, the acidic nature is not that much as compared to that of your phenol. So acidic nature of phenols is greater as compared to that of your alcohols. Okay, so phenols are more acidic than alcohols. So remember that phenols are more acidic in alcohols. Why? What is the reason? Because the OH group is attached to a more electronegative sp2 hybridized carbon. Okay, of the benzene ring. In alcohols, where the OH group is attached, it is attached to a sp2 hybridized carbon of a benzene ring. Okay. So what will happen to the electron density of the oxygen? It decreases, and therefore the electron density decreases, and therefore the polarity of the OH bond increases. Okay. Now, what it will undergo now here, when it is added in the water, okay, in the aqueous solution, it gives you a phenoxide ion. This phenoxide ion, it is resonance stabilized. Okay, it is resonance stabilized. So this charge, it can be resonance stabilized. So it will undergo resonance. Okay, it will undergo resonance. So these are the resonance structure of benzene. Okay, that is your phenoxide ion. Okay, so this is the resonance structure of phenoxide ion. So because the OH group is directly attached to sp2 hybridized carbon, which is more electronegative because this is a carbon of a benzene ring. Okay, so if the electron density on the O oxygen atom, it decreases. As a result, the polarity of the OH group increases. And the whatever the phenoxide ion has produced, this phenoxide ion is resonance stabilized. It can be resonance stabilized. Okay, it is resonance stabilized. So as a result, so this is more acidic than alcohols. Now when we compare alcohols, now take alcohols. Now in alcohols, if you put in aqueous solution, what it will give you? It will give you alkoxide ion and a proton is given out. Now this alkoxide ion, okay, the negative charge on the oxygen atom, it cannot be delocalized. Okay, this cannot be delocalized. It cannot go like this. The resonance structures cannot be possible in the alkoxide. But in case of phenoxide, it is possible, right? So because of this, phenols are more acidic than alcohol. So important question for us for 2 marks. Okay, important question. Please mark is important. So phenols are more acidic than alcohols. What is the reason? Write down the question. Phenols are more acidic than alcohols. Why? You can write like that. Phenols are more acidic than alcohols. Why? So you have to write the points. Okay. Fine. Is it clear? Shall we move for the next one?
Yes, ma'am.
Okay. So next is effect of substituents. Effect of substituents on acidity of phenols. Okay. On acidity of phenols. So which are the electron withdrawing groups, or what? Which is the electron? Yes. So which is the electron withdrawing group? So previously we have discussed about the electron donating group, right? So how is the effect of electron donating groups? So now we are going to see the effect of substituents like electron donating groups. Okay. So which are the examples? So please note it down. Nitro group, cyano group, aldehyde group, okay, and carboxylic acid, and the halogen. So halogens like fluoride, chloride, bromide. Okay, so these are the electron donating group. So it will give electrons. Okay, it is electron rich. So it will give electrons. So what is the effect of these substituents like the electron withdrawing groups? So electron withdrawing groups, what they'll do, they will delocalize the negative charge. Okay, they will delocalize the negative charge on the oxygen in phenoxide ion effectively. So what will happen? It will stabilize the phenoxide ion. What it will do? It will stabilize the phenoxide ion. So what will happen to acidic nature? The acidic nature will increase. The acidic nature will, or acidic strength will increase. Okay, it will increases. So this effect, it is more when electron withdrawing groups are present at ortho and para position. Suppose I have phenol. Suppose I have phenol. Okay, then I have a phenol with a nitro group. Okay, then I have a phenol with a nitro group at para position. Okay, then suppose we have a phenol at a ortho meta position. So that time, so how you will arrange the this uh, Yes, how will you arrange? So effect, how it will increase? So whenever the OH group is present in nitro group, so here it will be more. So when the nitro group, okay, when it is present at the ortho position, you can see that, sorry, when it is positioned at the para position, so here it is more. So the acidic nature will be more in case of first of your nitrophenol group. Okay, then it will be at the ortho. So then next will be at your ortho. Okay, and next will be your at, yes, at meta. So when the nitro group is present at meta, and then it will be at so only phenol. So the acidic nature, so because of the presence of nitro group at ortho and para position, it will be more. Okay, the acidic behavior of phenols will be more in case of para nitrophenol. Then it will be in case of ortho nitrophenol, and then at meta nitrophenol, and then at phenol. So this is the acidic nature of your phenol. So acidic nature, what will happen? It will be more, okay, when a electron withdrawing group is attached, okay, at ortho and para position. So para will be more. Understood? So the electron withdrawing groups are more now. So let us consider this one. So this is asked during exam. Okay, how it will be asked? Arrange the following. Okay, so in the increasing order of their acidic strength, like that it will be asked. So compounds will be given. So this is 2,4,6 trinitrophenol. Okay, so if more number of nitro groups are there, then what will happen? The acidic nature will be more. Okay, so this is nitro, and this is a para substituent. Okay, OH and NO2. So here you can see that. So in case of your first compound, the acidic nature is more because there are 3 nitro groups present. Here there are 2 nitro groups, here 1. So when the electron withdrawing groups are more, okay, the acidic nature will be more. So number of electron withdrawing groups, it will become more, will be the acidity. Now, one more question can be asked. Para-nitrophenol is more acidic than phenol. Can you give me the answer? Why the para-nitrophenol? Which is para-nitrophenol? This is a para-nitrophenol. Okay, I'll write the structure here. So para-nitrophenol, okay, this is the structure of para-nitrophenol. So this para-nitrophenol is more acidic than your phenol. What is the reason? Why the para-nitrophenol is more acidic than phenol? Your phenol? Yes. Just told you, because of the presence of, in the para-nitrophenol, what is present? The electron withdrawing group is present. So which is the electron withdrawing group? Nitro group. So what you have to write? In para-nitrophenol, the electron withdrawing nitro group, okay, it will show the inductive effect as well as the resonance effect. So because of that, it is more acidic than phenol. Okay, it is more acidic than phenol. Okay, so this is the reason. So like this, it is asked for 2 marks. Okay, so you have to note this important things. Okay, so just now we saw what? Whenever electron withdrawing groups are there, okay, electron withdrawing group will increase the acidic nature. Now suppose when electron donating groups are there. Now which are the electron donating groups? Like the methyl groups, amine group, okay, then your amide group, okay, then your alkoxy group, okay. So these are the electron donating group. Now, whenever electron donating groups are present, so what it will do? It will increase the electron density of benzene ring, and it will destabilize the phenoxide ion, and acidic nature or acidic strength will decrease. So whenever such this is present, okay, whenever such what is that? Atoms are present. Whenever such atoms are present on the your benzene ring, so what will happen to the acidic strength? The acidic strength will decrease. Okay, the acidic strength will decrease. Now, suppose I have this particular compound. Okay, I have this and okay, this. Can you tell me where the acidic this will be more? Phenol will be more acidic, or this is your
Phenol.
paracresol. Okay, so this is a paracresol. So paracresol is more acidic or phenol? So phenol is more acidic. Okay, so this paracresol is less acidic than your phenol. Okay, so phenol is more acidic. So whenever your electron donating groups are there, acidic strength will decrease. Okay, so the question can be in paracresol, why it is less acidic than phenols. Okay, so in paracresol, electron donating group is present, that is CH3 group is present. Because of that, it is less acidic than phenol. Okay, so like that the question is given. Now, suppose I give you I'll give you this, okay, some compounds. Now you have to remember how you have to arrange the this, okay. So CH3, CH2, CH2, OH. Okay, then will be your okay, then okay, okay. So here this is 1, 2, 3 nitrophenol. This is 3, 5 nitrophenol, and then phenol. Next is phenol, and next is methyl phenol. Methyl phenol. Yes, how will you arrange? Methyl phenol. Okay.
5.
First will be your
5.
okay. Let me give it A, B, C, D, E, and F. Okay, A, B, C, D, E, F. First will be your so if now there is a alcohol here and there is a phenol. So we know
Ma'am,
that
decrease to increase or increase to decrease, ma'am?
increasing order of their acidic strength. Okay, now we know that
D.
what see, we know first we have to see what all are, see these are nitro groups. Okay, so this will be more acidic. So we'll keep this later. Okay, nitro group. Now we have to see these three, 1, 2, and this. Okay, now here you can see, we know that phenols are more acidic, right? Phenols are more acidic than alcohols, right? Now here, which is the alcohol then? Which is the least
Phenol.
alcohol? This one. No, this, right? We are doing increasing order. Increasing means what? From lowest to highest. Now,
Yes, ma'am.
which is which is the so phenols are more acidic than alcohol, means alcohols are the least. Now in 1, 2, and 3, this 3, okay, 1, 2, and 3, which is alcohol? This one, right? So first will be your A. Got it?
Yes, ma'am.
Okay. Now you have to check in between these two. Now, what we know, whenever there is a electron donating group, okay, whenever there is electron donating group, what will happen? Electron donating group is present, the acidic strength will decrease. Now, in between phenol and this, which is least, it will be
Yep.
F. Yeah, so it is F. Okay. Now, next is your E. Next is your E. Now you have to see the number of nitro groups. Now here, between B, C, and D, which will come first? Now here there are 3 nitro groups. Here there are 2 nitro groups, and here 1. So this will be least,
C, ma'am.
right? So then will be your C. Then after that it will be your D, and next will be your B. Right. So like this is the increasing order of acidic strength. Okay. This is the increasing order of acidic strength. Got it? So like this, the acidic strength will increase. So from alcohols, so between alcohols and phenols, alcohol is least. Okay. Then phenols, then alcohols, then between phenols and because of the presence of electron withdrawing group, what will happen? The acidic strength will become less. So it will be F, then will be E. Okay. Then you have to see the number of nitro groups. So depending upon the nitro group, so if more nitro groups is there, more will be the acidic strength. Okay, so depending on that, we have arranged these all things. Okay, so like this,
Ma'am, if they are nitro or absent,
all.
ma'am, if nitro or absent, then what happened, ma'am?
Now, if nitro is absent, then it will become phenol only, no?
Yes, ma'am.
So
That one
because
is more.
now see here, now what I said you first will be alcohol, because alcohols are least. Okay, after that will be your now because of the first thing what it is, that alcohols are least acidic. Okay, they are least acidic, but phenols are more acidic. Phenols are what? Phenols are more
More acid.
acidic. Okay. Now, when we are comparing alcohols and phenols, phenols will be at the top prior. Okay. Then will be your alcohols. Now, when you have these electron donating or electron withdrawing groups, now what will happen when there is a presence of electron donating or electron withdrawing group? When electron donating groups are there, okay, like your methyl groups or amine groups, so that what it will do, it will decrease the acidic strength. Whatever the acidic strength is of the phenols and alcohols, it will decrease. Okay, and whenever electron withdrawing groups are there, like the nitro group, okay, then your cyano group, aldehyde group, carboxylic acid. So what it will do, it will increase the acidic strength. It will increase the acidic strength. So depending on that, again in that, how many number of groups are present? If more the number of groups, more will be the acidic strength, or it will be decreasing. So if electron withdrawing groups are more, then acidic strength will be more. If electron donating groups are more, again the acidic strength will go on decreasing. Like that it is. Okay. So we are putting some extra atoms on that. Okay, so when extra such atoms or substituents are present, so what will affect? Okay, how the acidic strength will affect of these alcohols and your phenols. Got it? Like this. Okay. Is it clear?
Yes, ma'am.
So like this, these questions are asked during CET also, like that. Okay, so some compounds will be given, and then you have to, so they'll give you like this options A, B, C, D. Okay, they will arrange some compounds in different order, like this A, then in some options B will be different. Okay, C, D, like this different options will be given. Means F is less than A, then is E, means like that. Some options will be given. Then by
Ma'am,
applying
then
your knowledge,
increase to decrease, we want to choose, no, ma'am.
Increase to decrease, then how you will do? Increase to decrease means first will be your nitrophenol, then right, this trinitrophenol, this compound. Now I'll mark it with black color. See, this will come
Ma'am,
first.
then what then now, ma'am? Or decrease to increase or increase to decrease, ma'am?
Now we have done from decrease to increase. We have okay, because alcohols are the least, right? Alcohols are the least here. So we have taken A first, right?
Okay, ma'am.
Alcohols are the least. Then comes your phenol. Okay, now between phenol and because of the presence of electron donating group, what we have just seen that paracresol is least. Okay, it is
Okay.
less acidic. So this will come next. Now, what is there? Phenol will come. Now, because of the electron, these are all electron withdrawing group. So more the electron withdrawing group, more will be the acidic strength. Now we are doing what from small to higher we are going, right? Suppose its acidic strength is 3. Suppose this is 3.2, this is 3.5, 3.6, 3.8, 4.2, like that. Got it? Now,
Yeah, ma'am.
here, so now here, what we have seen now at C, only 1 will come. So that C will come because it is value will be less. Now next is 2 nitro groups. So then this will come. Okay. And then because of 3 nitro groups, the acidic strength will be more. So it will come B. Okay, like that you have to arrange from increase from smaller to higher. Okay, acidic strength is nothing but because how the alcohols will react. Okay, now we have seen alcohols are least acidic, phenols are more acidic. Now because of the presence of substituents will be present. Now which are the different substituents? Some substituents are grouped under electron withdrawing groups and some are grouped under electron donating groups. Okay, so because of this presence of electron donating and electron withdrawing groups, so again the acidic nature will change of these alcohols and phenol. So when electron withdrawing groups are there, it will increase, acidic strength will increase, and when electron donating groups are there, the acidic strength will
Decrease.
decrease. Is it clear?
Yes,
Okay,
ma'am. Now I
is
have
it
got
clear
ma'am.
now? Okay, you just read it once more. Okay, and if you don't understand, tomorrow again we will discuss on this. Okay, so this is very important from exam point of view, all of you. Okay, if anybody didn't understand, you can ask this back, because from exam point of view as well as from CET point of view, the questions can be asked. Okay, so different compounds will be given, and as I have arranged from increasing and decreasing order, so like that different options will be given. You have to see the correct one and you have to choose this. Like that the question will be asked. Okay, next is the, so first we have seen what? First we have seen the reaction involving the OH bond, right? So that is the reaction with metals, so these were the things which we had discussed in our previous class. That is about the reaction with metals. Then we see acidic nature. Okay, acidity of alcohols and phenols we have discussed. Then the substituents, how the effect of substituents, that is when electron donating groups are present, electron withdrawing groups are present. Next is the esterification reaction. Very, very important from exam point of view. Please mark this important for 2 marks. Okay, so what are esterification reaction? Give example. So like this the question can be asked. What are esterification reaction? Give example. Okay. So esterification reactions are what? So when alcohols and phenols, when they react with the acid, okay, when they react with the acid, that is your carboxylic acid, or when they react with the acid chloride, or when they react with the acid anhydride, they will produce esters. They will produce what? Esters. Okay, they will produce esters. So what are esters? When alcohols and phenols, when they react with carboxylic acid, okay, acid chlorides and acid anhydrides, they produce what? Esters. Fine. So such a reactions are called as esterification reaction. And these esterification reactions, they how the reaction takes place in the presence of acid. Okay, in the presence of acids. Okay, in the presence of acid, this reaction takes place. That is in the presence of H plus ion. You can add acid like H2SO4. Okay, for esters, we are adding H2SO4. Okay, now how these reaction takes place? Now, either you can take alcohol. Alcohols are represented by ROH. Okay, or you can take AROH. What is AROH? Your aromatic ring. That is your phenol. So when phenol or alcohol, okay, when they reacted with the carboxylic acid. So let me take for carboxylic acid, in the presence of what? In the presence of a H plus ions, what it will produce? I'll show you how the reaction takes place. So Sorry, not this. So I'll take this only. What? So what is given out? H2O, right? So H2O. Now write the remaining things. R, O, C, double bond O, C double bond O, R dash. Is it clear? Okay. The same with the same with AROH. Okay. Or so it can react with alcohols also. It can react with phenols also. So if phenols react with this, how it will be? How will be the product? Just see. So it will be again water will be released out. Okay, plus H2O and AR. Okay, O, C, double bond O, R dash. So like this. Okay, so like this the product is formed. So these are the esters. Okay, R, O, C, double bond O, R dash is what? It is a esters. So these are what? These are esters. Got it? Yes? Fine. So these are the esters, esterification reaction. So now this is with carboxylic acid. Okay. Now this can react with your this also acid chlorides and acid anhydrides. Now if it reacts with acid chloride, okay. Now same ROH or AROH. Okay. When it reacts with acid chlorides, how do you write acid chloride? R dash C double bond O. Okay. Cl. So this is acid chloride plus R dash C double bond O Cl in the presence of H plus ions, in the presence of H plus ions. So this is the alcohol and this is a phenol. Okay. Now here how it reaction takes place. Now here what it will form? See here. What is given out? HCl, right? Plus HCl. So write the remaining RO C double bond O R dash. AR O C double bond O R dash. Again, ester, right? So like this, the esters are formed. So with acid chloride. So acid chloride, this is the reaction. Now next is with acid anhydrides. Okay. Now when alcohols, so alcohols, when they react with acid anhydrides. So how is acid anhydride? R dash C double bond O O R double dash C double bond O O. So this is an acid anhydride in the presence of H plus ions. What it will give? Just see. So it will give you
Aldehyde.
no, it will give you ester only. But what will be the side product? So one will be ester, here, RO. Okay. One will be ester, CR, R dash, C double bond, OH. So here, okay, this will get combined like this. We are producing esters. Okay, so what is this? So it will be R dash, C double bond, OH. So this is a carboxylic acid. Right, one will be byproduct is carboxylic acid and another is what? RO, C double bond O, R double dash. Again, ester. Got it?
Yes,
The
ma'am.
esterification reaction means what? We are producing esters. Okay, so alcohols and phenols, one is common. So you can take alcohols or you can prepare it from phenols also. But you can form esters with different reactants like carboxylic acid. With carboxylic acid, it will produce ester plus water. With acid chlorides, what it will produce? HCl plus ester. With acetic anhydride, what it will produce? It will produce
Ester.
carboxylic acid and ester. Okay, the byproducts are different, but ester is the common this product. Okay, so esterification reactions are what? Esterification reactions, we will produce esters. Okay, so the reactants are different. So phenol, alcohol or carboxylic acid, you will get water and ester. Then with acid anhydride, so this is acidic anhydride. Okay, this is acid anhydride. So with acid anhydrides, you will get again ester and carboxylic acid. Okay, then with acid chlorides, with acid chloride, what you'll get? HCl and ester. So just now I've shown you. So how the HCl, so HNCl, okay, HNCl, and remaining will be your ester. Is it clear? So yes,
Yes, ma'am.
confusion.
No, ma'am.
Okay, fine. So examples. Okay, so please go through these things. Okay, again I will not tell you some more because again it will be more confusion. Okay, so this all reaction, it will proceed in the presence of H2SO4. Okay, so what you do? So go through the acidity of phenols, acidity of alcohols, all these things. Okay, affecting group, electron withdrawing group. So these all you study. Okay, and also acidification reaction. All these three types. Okay, and if you did not understand anything, tomorrow again I'll explain. Okay. So uh, these this completes your what? This completes your reactions involving OH bond. Okay, cleavage
Ma'am,
at
your voice
OH bond.
getting break,
So
ma'am.
what we are doing, we are breaking this OH bond and new products are formed, right? So these are the reaction in which OH, the cleavage of OH bond takes place. So in tomorrow's class, let us discuss the reaction involving the cleavage of CO bond. Okay. Class, we have completed the reactions involving the cleavage OH bond. Okay. In tomorrow's class, let us discuss the reactions involving the cleavage at CO bond. Okay. So we are discussing two types, right? So alcohol